Okay, today we're going to talk about naming of two categories of acids, those being binary acids and oxyacids. Binary acids binary acids are acids that consist of hydrogen that are attached to another element such as fluorine or chlorine or iodine or bromine. Or out of group 16, something like hydrogen sulfide. So the first thing that you need to remember about binary acids is these are molecular compounds, and if they're in the gas phase, you would name this substance hydrogen by its full first name, and you would change the ending of fluorine to fluoride. The ide is important. The ide tells people that we're not talking about fluorine, we're talking about fluoride, and that is a different substance, has different chemical and physical properties. Now, this isn't an acid. This would be a molecular compound. It's a gas. When we bubble this gas into water, the gas dissolves into the water, and we symbolize that by writing AQ for the phase. AQ means dissolved in water. So once the hydrogen fluoride gas is bubbled into water, it is now considered an acid, and its naming will change, or its name will change. So now this is hydro. So there's the prefix. Then take the nonmetal, drop the INE off fluorine, and add an IC suffix. So this is called hydrofluoric acid. Hydrofluoric acid. Same principle applies with all of these. We would say, as a gas, this would be hydrogen chloride. Once the gas is bubbled into water, we would symbolize that with AQ, dissolved in water, and we would change hydrogen to hydro for the prefix. Chlorine, drop the INE off of chlorine, and add IC. So hydro prefix, X suffix, acid. So I think you get the idea for the other two, but let's talk about this last one. So some people call this dihydrogen sulfide. More people call it hydrogen sulfide. It's been around so long that it generally is just known as hydrogen sulfide. So it's not following the naming rules that we generally consider for molecular compounds. So again, this is a gas. And this is the gas that you smell around that smells like rotten eggs. This is a common description of this gas, hydrogen sulfide. When we bubble this in water, again, same chemical formula. The only difference is now it says aqueous. Aqueous again means dissolved in water, and so we would call this hydrosulfuric acid. Now, I stress this one because I find some students confuse hydrosulfuric acid with sulfuric acid, and they are totally different types of acid. Hydrosulfuric acid is a weak acid. Sulfuric acid is an oxyacid, and it's a strong acid. So if you were doing an experiment and it asked you to pour hydrosulfuric acid solution into, say, a column for separation, and you poured instead sulfuric acid, you would get a totally different reaction. In fact, it may be a violent reaction. So it's important that you know the difference between hydrosulfuric acid and sulfuric acid. Again, this set of acids are called binary acids. They consist of hydrogen with another substance. Now, there are acids that do not follow this rule, and let me point this one out. So here we have hydrogen with cyanide. So this isn't binary, right? We have hydrogen, we have carbon, we have nitrogen. It's not two things, it's three things. But hydrogen cyanide's been around so long that when we bubble the gas into water and it dissolves, we call this hydrocyanic acid. So that one's when it's a little sometimes tricky. Just remember it that HCN, hydrogen cyanide, becomes hydrocyanic acid. These are binary acids. All right, let's talk about the other classification of acids, and that is oxy or oxo. What I find is the people who struggle with naming oxy or oxo acids are people who have not memorized their polyatomic ions. So what are polyatomic ions? Two or more different elements bonded together with a charge. So that's a polyatomic ion. And so you have to have this memorized. This substance is called sulfate. I don't know what the problem is here. Well, let me erase this part. Okay. You're seeing this in real time, untouched. I am drawing on a Wacom board, and it is more difficult. I don't see what I'm actually writing. It's like looking at it on a computer screen in front of me, and then writing on this blank surface, which makes it difficult. So this is the sulfate ion. And here's something to remember. You know, my students, they sometimes complain about memorizing all the polyatomic ions, and there are some tricks, and the one trick is that if you knock an oxygen off and the charge remains the same, the sulfate ion becomes the sulfide ion. So you're not really memorizing each one individually. Another example would be this, that you memorize this ion called the chlorate ion. And then you knock an oxygen off. And what do you think the name of that is? You're correct. It is the chloride ion. But then it gets a little tricky here. We can knock another oxygen off, and we get ClO negative. And so what do you think that is? Well, we've already used chlorite. So if you've had medical terminology or classical words, you may Latin, maybe you know that there's a word named hypo, or it means less. So hypochlorite, like hypoglycemic. So the hypochlorite ion. We can also have more than 3 oxygen. We could have 4 oxygen with the same charge. So what do you think the name of that one is? Well, you may be thinking hyperchlorate, and that's not a bad guess, but we actually simplify that and call it perchlorate ion. So you're probably wondering why we are going over polyatomic ions when this particular video is on naming. Well, here is how these are all, notice these all contain oxygen, and they're all charged ions, negatively charged cations is what we would say. I mean anions. Oops, sorry about that. So they're anions. So hydrogen, we generally think of it as an ion. We think of it as hydrogen with a positive charge. So how many hydrogen ions do we need to add to a sulfate ion in order for it to be neutral? And you would say 2. And technically, these are not ions to begin with. This is a covalent compound where it's the sharing of electrons, where the oxygens are attached to the sulfur. And I'm not drawing a Lewis structure here. I'm just drawing a structure to kind of give you an idea of what this would look like. So the hydrogens are attached to the oxygens are attached to the sulfurs. And it is, notice you don't see any positive and negative charges. This is not an ionic compound. So to name this substance dissolved in water is called sulfuric acid. And this is what I was talking about. This is a different substance than hydrosulfuric acid. So this is sulfuric acid, also called car battery acid. Sulfuric acid. So you go, well, how am I supposed to memorize this stuff? Well, it's easy. There's a mnemonic, a memory device to help you. I ate something icky. Eight ions end in ic acids. I ate something icky. Now, I don't know what the mnemonic is for sulfurous. The sulfite ion becomes sulfurous acid. So we can have H2SO3, and this acid is called, and again, dissolved in water. This is called sulfurous acid. sulfurous acid. So if you know the mnemonic for ite to OUS, email it to or send it to me on YouTube, and I'll post that. So I think it's important that mnemonics are important. No, it's not truly learning it, but it is a memory device to help you learn it. So I agree, after time, you'll know these and you won't really use this memory device. But starting out, it seems a little overwhelming. Seems like you have to memorize quite a bit here. But there are tricks like knowing when we knock an oxygen off, it goes from sulfate to ite. And then knowing the sequence of knocking one or two oxygens off, we go from ite to hypochlorite, or if we add an oxygen, it's goes per. So that's important. It makes it easier. So the main thing is you shouldn't hear the word hydrogen in these acids. There's no hydro or hydrogen. It's understood how many hydrogens are attached because the polyatomic ion is a -2 charge. Therefore, you need 2 positive hydrogen ions to be neutral. Just keep in mind that there's truly no charge at this point, that the structure is a covalently bound structure. Now, I agree, once we put it in water, what happens is sulfuric acid reacts with water. I'm going to use the Bronsted-Lowry definition. Bronsted-Lowry definition says an acid donates a hydrogen ion to water, and the water becomes the hydronium ion, which is what gives an acid its chemical properties. And then what's left over is what we call the conjugate base. That's the substance left that has lost a hydrogen ion. All right, conjugate base. Notice the arrow here goes only one way. Because sulfuric acid is a strong acid, 100% of the sulfuric acid is converted to hydronium ion and hydrogen sulfate ion. So that's the naming process. For binary acids, you have hydrogen bonded with another element. You add enough hydrogen to have the outer shell of the central atom complete, 8 electrons usually, and you will have a hydro prefix and an ic suffix. So hydrochloric, hydrobromic, hydroodic, hydrosulfuric. The other type of acid, called the oxy or oxo acids, they must have oxygen in them. They begin as polyatomic ions, and from these polyatomic ions, and knowing the charge of the polyatomic ion, we know how many hydrogen ions have to be added in order to have a neutral substance, and that's how we determine the chemical formula for those acids. So once we know these are acids and that we know the chemical formula, it's a matter of naming. If the ion ends in ate, the acid ends in ic. If the ion ends in ite, the acid ends in OUS. And the mnemonic is I ate something icky. I hope that helps. Let's do one more. Let's do a test here at the end. This is what's going to test if you can understand what we've been talking about. Tell me the name of this acid. Tell me the name of this acid. This acid would be phosphoric acid. Because this is a polyatomic ion, phosphate with the -3 charge. That's why we have to have 3 hydrogens. So this is phosphoric acid. It's a oxy acid. We look at the next acid. It's a binary acid. It consists of hydrogen and phosphorus, or the phosphide ion. And so we would have hydrophosphoric acid. And we call it hydrophosphoric. It is dissolved in water. If it's just pH 3, as a not dissolved in water, we would call it, that actually has a common name called phosphine. Which is a poisonous gas. All right, I hope that helps. I have another video on naming that will break down ionic and molecular compounds, but I needed to make another video here to show how you name the 2 categories of acids that you generally come in contact in general chemistry with, which are binary acids and oxy acids. I hope this helps. If you have that mnemonic for IOUS, please post it on YouTube. Thank you.